Hello dear students, all of you welcome to Vidyan classes. Today we will discuss on properties of determinants. First property, that is called reflection property. It is defined by the value of a determinant remains the same if its rows and columns are interchanged. The value of a determinant remains the same if its rows and columns are interchanged. Symbolically, it is written as ith row is replaced by ith column and ith column is replaced by ith row. It is the symbolic form of the given statement. Ith row is replaced by ith column and ith column is replaced by ith row. Verification. Let del be the determinant having elements A 0 0 x b y 0 0 c. Expansion along row 1, that is first row. Value of the determinant remains the same expanding any one of the rows or columns. This concept is discussed in previous classes. Value of the determinant remains the same expanding any one of the rows or columns. For easier calculation, we will expand that row or column which contains maximum number of zeros. Here, first row contains 2 zeros and third row contains 2 zeros and second column contains 2 zeros. So, we will expand along first row or third row or second column. The value of the determinant remains the same expanding any one of the rows or columns. Expansion along first row. Del is equal to A11 into cofactor of A11 plus A12 cofactor of A12, A13 cofactor of A13. It is the element of A11 represent the element of first row and first column, A12 represent the element of first row second column, A13 represent the element of first row and third column. Capital Aij represent the cofactor of the element Aij. It is the definition of expansion of a given determinant. A11 is A, its sign is positive, into minor of the element A11, which represent deleting the first row and the first column, it gives by 0c. The sign of A11 is positive. The sign of A12 is negative and A12 is 0 into A12. The sign of A13 is positive and A13 is 0 into A13. A into BC minus 0 minus 0 plus 0 which is equal to ABC. Clear? The value of the determinant is the ABC. Apply ith row is replaced by ith column and ith column is replaced by ith row. That means first row will be first column, second row will be second column, third row will be third column. Let del will be del 1. Applying this concept. Now del 1 is equal to first row is replaced by first column and first column is replaced by first row. Ith row is replaced by ith column and ith column is replaced by ith row. A00 is replaced by AX0. AX0 is replaced by A00. It is the second row, will be second column XBY. It is the third row, will be third column, that is 00C. Expansion along that row or column which contains maximum zeros. Here first column and the third column contains maximum zeros. Expansion along C1, that means first column. Del 1 is given by A11 into cofactor of A11 plus A21 cofactor of A21, A31 cofactor of A31. Expanding along first column. Clear? A11. A1, it is the element of first row and first column, that is A. Cofactor of A11, that means deleting the first row and the first column, it gives B0, determinant having elements B0, Y, C. The sign of A21 is negative and A21 is 0. A21, 0 into A21 is 0. The sign of A31 is positive and the element is given by 0. A31. Clear? It gives A BC minus 0 minus 0 plus 0 which is equal to ABC is equal to del. The value of del is ABC, which implies del is equal to del 1. The value of a determinant remains the same if its rows and columns are interchanged. Interchanging the given determinant del, we get del 1. The value of del and del 1 are same. Therefore, property 2 is verified that true. Clear? Clear? Okay. Property 2, that is called zero property. If all elements of a row or column are zero, then the determinant is zero. Verification. Let del be the determinant having elements 0, 0, 0. A2, B2, C2. A3, B3, C3. Expansion along first row. Since first row contains maximum 0, for easier calculation, expand that row or column which contains maximum number of zeros. First row contains 3 zeros. Del is defined by A11, cofactor of A11, A12, cofactor of A12, plus A13, cofactor of A13. A11 is 0 into capital A11. A12 is 0 into capital A12. A13 is 0, which is equal to 0 plus 0 plus 0 is equal to 0. Implies del is equal to 0. Let del 1 be the determinant having elements A1, 0, C1, A2, 0, C2, A3, 0, C3. Expansion along column 2. Since column 2 contains maximum zeros, del 1 is defined by A12, capital A12. 0 is the element of first row and the second column, plus this 0 is the element of second row and the second column. A22. This 0 is the element of third row and the second column. A12, element of first row and the second column, it is 0, A12, plus A22 is 0, capital A22, A32, element of third row and the second column, it is also 0, A32, which is equal to 0, plus 0 plus 0 is equal to 0. Implies del 1 is equal to 0. Therefore, property 2, which is called zero property, is verified. That row. If all elements of a row or column are 0, then the determinant is 0. Clear? If any one of the rows or columns whose elements are all 0, then the value of the determinant is 0. It is called the zero property. Are you clear? Okay. Write down. Property 3, that is switching property. The absolute or modulus value remains the same, but the sign of the determinant changes if any two adjacent rows or columns are interchanged. The absolute or modulus value of the determinant remains the same, but the sign changes if any two adjacent rows or columns are interchanged. Symbolically, it is written as ith row replaced by I plus 1 row, and I plus 1th row is replaced by ith row. Ri and R I plus 1 are two adjacent rows. Similarly, ith column is replaced by I plus 1th column, and I plus 1th column is replaced by ith column. This and this are two adjacent columns. Verification. Let del be the determinant having elements A, B, 0. 0, X, 0. P, Q and R. It is a determinant of order 3. Row 2 contains 2 zeros and row 3 contains 2 zeros. For easier calculation, we will take that row or column which contains maximum zeros. Expanding along second row. Second row contains 2 zeros. Now, del is equal to A to 1. It is the element of a second row and a first column. A to 1 into cofactor of A to 1 plus A to 2 into cofactor of A to 2 plus A to 3 into cofactor of A to 3. It is the expansion of the determinant along second row. A to 1, that is 0. A to 1 is 0 into A to 1. A to 2, that is X, and its sign is positive. X into A to 2, deleting the corresponding row and column. Minor with the proper sign is called the cofactor. Its sign is positive. X into minor of A to 2, deleting the corresponding row and column. It is the second row, it is the second column. Gives A 0 P R. A to 3 is given by 0 into capital A to 3. It is 0 plus x into AR minus 0 plus 0 which is equal to ARX. The value of the determinant is ARX. Applying first row replaced by second row and the second row is replaced by first row. Let del will be del 1. So del 1 is equal to first row is replaced by second row 0 x 0. Second row is replaced by first row a p 0. Third row remains silent. Clear? Row 1 contains two zeros. Expansion or expanding along first row. Del 1 is equal to A11 into cofactor of A11 plus A12 cofactor of A12 plus A13 cofactor of A13. A11, A12, A13. A11 is given by 0 into A11. A12, its sign is negative, minus x, minor of A12, deleting the first row and the second column. Sign of A12 is negative and A12 is given by x, minus x into deleting the corresponding row and the column of x, it gives A0 PR. A0 PR plus A13 is given by 0 into A13 which is equal to 0 minus x AR minus 0 plus 0 which is equal to minus XAR, which implies del 1 is equal to XAR. ARX is minus del. Del 1 is equal to negative of del. But modulus of del 1 is equal to modulus of del. Since it is defined by mod of x is equal to mod of minus x for all x belongs to R, set of real numbers. The absolute value remains the same, but the sign changes. If two adjacent rows or columns are interchanged, absolute value remains the same. That means modulus value remains the same, but the sign changes. Del 1 is negative of del. If two adjacent rows are interchanged, R1 is replaced by R2 and R2 is replaced by R1. Clear? Similarly, apply C2 is replaced by C3 and C3 is replaced by C2. Let del will be del 2. So del 2 is equal to determinant. Row 1 remains silent, column 1 remains silent and P. Column 2 is replaced by column 3 and column 3 is replaced by column 2. It is 0, 0, R, BXQ. BXQ. Clear? Value of the determinant remains the same, expanding any one of the rows or any one of the columns. Expanding along row 2. Since row 2 contains 2 zeros. Also we can expand it along column 2 since column 2 contains 2 zeros. Value of the determinant remains the same, expanding any one of the rows or columns. Expanding along row 2. Del 2 is equal to, it is the element of a second row and first column, A21 into cofactor of A21 plus A, it is the element second row and second column, A22. Expanding along row 2, A23 into cofactor of A23. Expanding along row 2, A21 is 0 into A21. A22 is also 0, A22. The sign of A23 is negative. Its sign is negative, so it is minus x into minor of A22. Deleting the second row and third column, it gives A0 PR, which is equal to 0 plus 0 minus XAR, which is equal to minus XAR, which is equal to minus del. Since del is equal to ARX, del 2 is equal to minus del. But modulus of del 2 is equal to modulus of del. Modulus of ARX is same as modulus of minus XAR. Since x mod is equal to mod of minus x for all x belongs to R. Clear? Value changes. The sign. The absolute value, absolute or modulus value remains the same. Modulus value remains the same, but the sign changes since del 2 is negative of del. Del 2 is negative of del, but mod of del 2 is equal to mod of del. Since it is defined by mod of x is equal to mod of minus x for every real numbers. Therefore, property 3 is verified that true. That means absolute value of the determinant remains the same, but sign changes if two adjacent rows or columns are interchanged. Are we clear? Okay. Write down. Property number 4. It is the second switching property. The statement is given by the absolute or modulus value remains same, but sign of the determinant changes if any two rows or columns are interchanged. Simplically, it implies ith row replaced by jth row and jth row is replaced by or replaced by ith row, or ith column is replaced by jth column, or jth column is replaced by ith column. The absolute or modulus value remains the same, but the sign of the determinant changes if any two rows or columns are interchanged. In property number 3, we have discussed the sign of the determinant changes if any two adjacent rows or columns are interchanged. Here, if any two rows or columns are interchanged, then the sign of the determinant changes. Clear? Verification. Let del be the determinant having elements A1, B1, C1, A2, B2, C2, A3, B3 and C3. Applying first row replaced by third row and third row replaced by first row. Let del will be del 1 and del 1 is equal to A3, B3, C3, A2, B2, C2, A1, B1, C1. First row replaced by third row and third row replaced by first row. Let del will be del 1. Now to show del 1, del is equal to negative of del 1. Second condition, modulus of del is equal to modulus of del 1. To satisfy the given statement, we have to show these two conditions. Del is equal to negative of del 1 and the modulus of del is equal to modulus of del 1. That means absolute or modulus value remains the same, but the sign of the determinant changes if any two rows, not adjacent, any two rows or columns are interchanged. Del is equal to Del is the determinant having elements A1, B1, C1, A2, B2, C2, A3, B3, C3, which is same as negative of A2, B2, C2, A1, B1, C1, A3, B3, C3. Since property 3, R1 is replaced by R2 and R2 is replaced by R1. According to property 3, if two adjacent rows or columns are interchanged, then the sign of the determinant changes. Here R1 and R2 are two adjacent rows interchanging. Row 1 and row 2 will get a negative sign. It is the property number 3. According to property number 3, this is same as this. Which is same as minus into minus A2, B2, C2, A2, B2, C2, A3, B3, C3, A1, B1 and C1. Since interchanging row 2 and row 3, row 2 and row 3, interchanging row 2 and row 3, according to property 3, the value of the absolute value of the determinant remains the same, but the sign changes if two adjacent rows are interchanged. It is property 3. That is property 3. According to property 3, here row 2 and row 3 are interchanged, so there exists a minus sign. Again, it is a minus into minus into minus A3, B3, C3, A2, B2, C2, A1, B1 and C1. Here row 1 and row 3 are interchanged. Row 1 and row 2 are interchanged. If two adjacent rows are interchanged, then the sign of the determinant changes. It is the property 3, which is same as minus A3, B3, C3, A2, B2, C2, A1, B1 and C1, which is same as negative of. It is taken as del 1. It is same as del 1. Negative of del 1. That implies del is equal to minus del. Del is equal to minus del 1. The first case is proved. It is also true, and mod of del is same as mod of del 1. the absolute value is also same. Since x mod is equal to mod of minus x for all x belongs to real set. Since here del 1 is negative of del x, mod of x is equal to mod of minus x. Since del 1 is negative of del, this is equal to this. So the statement is verified that true. Interchanging the rows Ri and Rj, that means Ri means ith row and Rj means jth row. Interchanging any two rows, here I not equal to j, I not equal to j. Interchanging any two rows, the sign of the determinant changes. The sign of the determinant changes, but the absolute or modulus value remains the same. Interchanging any two rows. Similarly, interchanging any two columns will get the same result. Apply C1 is replaced by C3 and C3 is replaced by C1. Let del will be del 2. Let del will be del 2. Here del 2 is equal to interchanging column 1 and column 3. Del is given by this C1, C2, C3, B1, B2, B3, A1, A2, A3. Interchanging column 1 and column 3. Let del will be del 2. Here del 2 is equal to this. Now to show first del is equal to negative of del 2. Second, modulus of del is equal to modulus of del 2. Which satisfy the given statement. These two conditions satisfy the given statement. Del is given by A1, A2, A3, B1, B2, B3, C1, C2, C3, which is same as negative of B1, B2, B3, A1, A2, A3, C1, C2, C3. Since C1 and C2 are interchanged, according to property 3, there exists a minus sign. The absolute value or modulus value of the determinant remains the same, but the sign changes if two adjacent columns are interchanged. C1 and C2 are two adjacent columns, which is same as minus into minus B1, B2, B3, C1, C2, C3, A1, A2, A3. Here C2 and C3 are interchanged. So there exists a minus sign. According to property 3, which is same as minus into minus into minus into determinant having elements C1, C2, C3, B1, B2, B3, A1, A2, A3. Since C1 and C2 are interchanged, so there exists another minus sign, which is same as minus of determinant C1, C2 and C3, B1, B2, B3, A1, A2, A3. When two columns, that is C1 and C3, are interchanged, there exists a minus sign. The sign of the determinant changes. Del is the negative of this, which is given by minus, it is the del 2. Del is equal to negative of del 2. Implies this, del is equal to minus del 2. And modulus of del is equal to modulus of del 2. Since mod of x is equal to mod of minus x for all x belongs to R. In properties 2, we have if any two adjacent rows or columns are interchanged, then the sign of the determinant changes. In property 4, if any two rows or columns are interchanged, the sign of the determinant changes. Here C1 and C3 are interchanged. Here R1 and R3 are interchanged. But the sign changes. Sign changes. And the absolute value or modulus value remains same. Clear? Therefore, property 4 is verified that true. The absolute or modulus value of the determinant remains the same, but the sign changes if any two rows or any two columns are interchanged. Are you clear? Okay. Write down proportionality property. The statement is given by if any two rows or columns of a determinant are identical, then value of the determinant vanishes or 0. If any two rows or columns of a determinant are identical, that means all corresponding elements are same. The constant of proportionality is 1. Then the value of the determinant vanishes. The value of the determinant vanishes if any two rows or columns are identical. Verification. Let del be the determinant having identical rows or columns. Let deal with the determinant having identical rows or columns. Interchanging any two rows or columns implies del is equal to negative of del. Since sign of the determinant changes if any two rows or columns are interchanged. Sign of the determinant changes if any two rows or columns are interchanged. It is a property 4. According to property 4, if any two rows or columns are interchanged, the sign of the determinant changes. Interchanging any two rows or columns implies this del is equal to minus del, which implies this 2 del is equal to 0. Since del contains identical rows or columns, interchanging any two rows or columns implies this del is equal to minus del. Since sign of the determinant changes if any two rows or columns are interchanged, which is discussed in property number 4. 2 del is equal to 0 implies this del is equal to 0. Hence, the statement is proved that true. Hence the statement means property 5. Hence the statement is proved that true. For example, 1, 2, 3, 4, 5, 6, 1, 2, 3 is equal to 0. Row 1 and row 2 are identical. Row 1 is equal to row 3. Row 1 contains 1, 2, 3. Row 3 contains 1, 2, 3. According to property 5, the value of the determinant vanishes if any two rows or columns are identical. Example 2, 3, 5, 9, 0, 1, 2, 3, 5, 9 is equal to 0. Since column 1 is the same as column. Clear? Value of the determinant vanishes if any two rows or any two columns are identical. Clear? Okay. Next property number 6. that is called scalar multiple property. If each element of a row or column of a determinant are multiplied by a non-zero constant k, then its value gets multiplied by k. If each element of a row or column of a determinant are multiplied by a non-zero constant k, then its value gets multiplied by k. Let del be the determinant having elements a 0 0, x y 0, p 0, suppose it is z, and q. Implies the value of del is equal to a into, for easier calculation we will expand along row 1 or along column 2, since row 1 and column 2 contains maximum zeros. For easier calculation, expand that row or column which contains maximum zeros. Expanding along row 1. The sign of A is A into minor of A, that is YZ 0 Q. It is 0, it is also 0. Expanding along row 1 is same as A Y Q. The value of the determinant del is A Y Q. According to the given statement, k into del is equal to k into del, means del is the determinant having elements a 0 0, x y z, p 0 q, which is same as multiplying k along row 1. It gives k into a, k into 0 is 0, k into 0 is 0, multiplying k along row 1, it gives ka 0 0, x y z, p 0 q, which is same as a 0 0, kx, ky, kz, p 0 q, which is same as a 0 0, x y z, multiplying k along row 3, kp 0 kq, which is same as multiplying in column 1, ka, kx, kp, 0 y 0, 0 z q, which is same as multiplying k not equal to 0, k is the non-zero constant, multiplying k along column 2, it gives k into 0, that is 0, sorry, a x p, k into 0 is 0, k into y is ky, k into 0 is 0, k into 0 is equal to 0, it is 0 z and q, which is same as multiplying k along column 3. The first column remains silent, a x p. Second column remains silent, it gives 0 y and 0. Multiplying k along column 3, which is 0, kz and kq. All are same. According to the given statement, if each element of a row or column of a determinant are multiplied by a non-zero constant, here k is multiplied along row 1, here k is multiplied along row 2, here k is multiplied along row 3, here k is multiplied along column 1, here it is k is multiplied along column 2, and here k is multiplied along column 3. If a non-zero constant is multiplied with a given determinant, then it will be multiplied in any one of the rows or columns. Or if each element of a row or column of a determinant are multiplied by a non-zero constant, then its value gets multiplied by k. In other words, we can say, if a non-zero constant is multiplied with a determinant, then it will be multiplied in any one of the rows or columns. All are equal. K del. Del is given by K A Y Q. K del. The value of del is A Y Q, which is same as this determinant. The value of this determinant, this value will be K del is K A Y Q. Now expanding this determinant. Now expanding A 0 0, X Y K Z, P 0 K Q. Row 1 contains maximum 0 or column 2 contains maximum 0. So we will expand along row 1 or column 2. Expanding along column 2. The sign of 0 is negative, it is 0. The sign of y plus minus plus, that is positive. Y into deleting the corresponding row and column, it gives, deleting this row and this column, it gives, that means the minor of y is A0 P AQ, which is same as y A K Q, which is same as K into A K into A Y Q, which is equal to K into del, which this value K del means A Y Q. Expanding this determinant, it gives the same result, that is K into del. Del means A Y Q. Similarly, taking this determinant A 0 0, Kx, Ky and Kz, P 0 Q, which is same as A into, expanding along first row. Dealing the first row and the first column, it gives K, Y, Q minus 0 expanding along row 1 minus 0 plus 0 which is equal to k a y q which is equal to k. All determinants this all gives same result, that is k tail. Hence the statement is true. If each element of a row or column of a determinant are multiplied by a non-zero constant, then its value gets multiplied by del. Here the value is a y q. The non-zero constant is multiplied with the given determinant, that is del. In other words, we can say if a constant k is multiplied with a determinant, it will be multiplied in any one of the rows or any one of the columns. There are 6 forms, all are same. 1, 2, 3. If a constant k is multiplied with a determinant, it will be multiplied either in first row or second row or third row or first column or second column or third column. Hence the statement is hence property 6 is proved that true. Clear? It gives k it is del. K del is equal to this. Expanding this determinant, expanding this determinant, it also gives k del. Expanding this determinant, it also gives k del. All are same. Are you clear? Okay. Write down